Hello, good morning everyone. Today, inshallah, we will continue. I believe in the previous lecture, we already started working with determinant. Today, this is our third lecture. I'm sorry, I forgot to change the lecture number. We are in the fourth week, but this is our third lecture. I want you to have an attention for the row operations in specific. I was just telling you about this. The differences between the row operations in matrices and the corresponding row operations in determinants. This part is really very important. It's a little bit confusing if you didn't study well the properties of the row operations in matrices and the determinants. We will talk a lot about determinants today in specific. So, as you can see, this is our course contents. Okay, we already finished the matrices and the relations and the operations and everything. It's your own responsibility to review it more than once. Please don't watch the videos, just watch the videos, resolve the problems, do the activities, and solve the exams. This is really major. The linear equation, system of equations, we already did go through it, either by using the determinants, as you will see today. I believe in the previous lecture, we already started to know how to solve the system of equation, the Cramer system, how to solve it, and so on. So now you can go through linear equations perfectly. I want you to review in all times the classification of the solution of a system of equations and the names of the solutions. It's consistent case, it's inconsistent case, it's consistent but determined, it's consistent but indeterminate, which one of them is infinite number of solutions, how to determine the degrees of freedom. This is essential. Then today we will talk about the determinants in details. We already know a lot about them at the time being, but we will finish this part. Next lectures of the next week, hopefully we will go through vector spaces, and this is a very important chapter. It needs attention, it needs working, and it will cover all the previous knowledge in it. I will start this chapter with some information about matrices and determinants both together. So we will start in this chapter, solely square matrices. We will talk in specific about square matrices. All of you now know the square matrix is the matrices with number of rows equal to the number of columns. So A belongs to a square matrix with M. Okay, it is invertible if and only if the rank of A is equal to M. Remark that this statement, rank of A is equal to M, it is analogous to non-singular matrices. They are the same. If I told you it's a non-singular matrix, so the rank of this matrix will equal to the number of the rows. Okay? So it is invertible. So these three meanings, it's really very important, and let's link it together. Number one, as I told you, non-singular matrix, it means the determinant of this matrix doesn't equal to 0. And it means at the same time that the rank of this matrix is equal to the number of rows, because it's going to be a square matrix. You can't get an inverse for non-square matrices. The inverses are for square matrices. Okay? You have to link all of this together. Here he's telling you about if we have a square matrix, but with order 1, dimension 1, it means one element. Am I right? One row, one column. So it's going to be one element. And it is invertible just only when this element doesn't equal to 0, because it contains just only one element. So the determinant of a 1 by 1 matrix is the number. If I told you the matrix, for example, if I told you the matrix 3, that's a 1 by 1 matrix. Okay? The rank of this matrix is 1, and it doesn't equal to 0, because simply this number is not equal to 0. Okay. For matrices with n, it means a 2 by 2 matrix, which contains 2 rows, 2 columns. Okay. It's gonna be invertible. It's gonna be non-singular if the values of the determinant assigned to this matrix doesn't equal to 0. How to evaluate the determinant of this matrix? Miss Nada, you already know this. I will get the multiplication of the elements of the principal diagonal minus the multiplication of the elements of the secondary diagonal. So simply it's A11 times A22 minus A12 times A21. It's written in front of you. So still introducing how to evaluate a 2 by 2. As I told you, those slides are specific and details, taking step by step how to evaluate determinants and the principal knowledge from the beginning. This slide, it's talking about when a 2 by 2 is equal to 0. The cases of an O when a 2 by 2 matrix, its determinants are equal to 0. I will skip it, it's not very containing that much knowledge, but I will skip it and I will come to this part. For A, which belongs to an n by n matrices of general numbers of constants, with n is greater than or equal to 2, given I and j from 1 up to n, so I and j are counters or counting methods starting from I equal to 1 up to n, in order to go through the rows or columns. We will write A of I and j as the matrix. This is a matrix, A of I and j, which belongs to the set of square matrices, but with dimension n minus 1 times n minus 1. What's he trying to explain here, Miss Seda? He's explaining that if I have a matrix n by n, if I want to get one of the matrices belongs to a certain element, okay, let's say the element I and j, I will go to this element I and j, I will remove the rows and columns, and then I will have a matrix, but it will be from the dimension n minus 1, n minus 1. For example, in order to name this at once, for example, if I have a 3 by 3 matrix, which belongs to the set of n by n, that's a 3 by 3 matrix. Here we go. That's 3, 4, 1, snap, 2, 0, 3, please give yourself 4. Okay, negative 1, 1 and 2. That's a 3 by 3 matrix. If I want to get the matrix assigned for 1 and 2, the element 1 and 2, it's very simple. All I have to do is to go for the first row and for the second column. Deleting this row and column, the remaining matrix will be, so deleting the first row, second column, the remaining matrix will be 2, negative 1, 3, and 2. You already know about this. It's going to be n minus 1 times n minus 1 dimension. So if this matrix is a 3 by 3, this one is going to be 2 by 2. If this matrix is 4 by 4, so just getting one of the matrices relative to each number of the numbers of this matrix, it's going to be let that dimension by 1. This is what is stated here. So if A is an n by n matrix, and n is greater than or equal to 2, if you want to get the matrix A of I and j, which it will belong to n by n minus 1, n minus 1 in columns. For the matrices obtained from A by removing the lines and columns. We need them at the time being it's an introduction to how to evaluate the value of a determinant by the cofactor method. You already taught it previously. But this is the correct order. So he's starting with you from a general matrix n by n. Now I know that corresponding to each one of the elements, there is a cofactor. How to get the cofactor? Just eliminating the row and the column. Then you will have a matrix, give them the dimension of the first by 1. Okay? He's just introducing them at the time. I'm telling you, introducing the cofactor matrix. Okay, so here, for example, if we have A, which is 3 by 3, if I want to get the matrix 1, 2, I will just remove the first row and the second column. If I want to get the matrix corresponding to the elements 2 and 1, I will go to the second row first column, so it's going to be 2, 3, 8, and 9, and the dimension exactly as I told you. If I want to get the matrix which is corresponding to the element 1 and 1, all I have to do is to eliminate first row first column, so the numbers are 5, 6, 8, and 9, and that's going to be a matrix 2 by 2. Okay? Just consolidating or confirming this fact. If I want to have a determinant, so it's just only introducing how to evaluate the determinant. Okay, are you with me? So, for A, which contains each element of I and J and belongs to the set of square matrices n by n, the determinants of A denoted by det A, that's the symbolization of a determinant, or simply I can write two lines and the bottom A, which means the determinant corresponding to the matrix A. معايا فريق؟ Okay, perfect. It is the element of K defined as follows. If n equal to 1, so the determinant will be this number. So if I have a 1 by 1 matrix of 5, so the determinant will be 5. Okay, if I want to get for n greater than 1, starting from 2 and above, so the determinant of A will be, please do focus. It's going to be A11, which is the element at the certain row or column as we will see. Then it's going to be -1 to the power of the sum of I and J. Then it's going to be the determinant of the matrix that's less than the main matrix by 1. So if I have 3 by 3, I will try to choose one of the rows and I will start evaluating each one of these determinants. By the idea, if I have a 2 by 2 matrix, let's do this rule, which is called the Laplace rule. You will see it in the coming slide. If I want to evaluate the value of the determinant of this matrix for A, how to evaluate it? Farid, I'm sorry. F issue. Okay, Farid, how to evaluate the value of this determinant? Determinant. That's a 2 by 2. Multiplying the elements of the principal diagonal minus the elements of the secondary diagonal. So it's going to be simply, we already know that. It's going to be A11 times A22 minus A12 times A21. Okay? We already practiced this long time ago. But from where it came from this rule. Okay, I will start step by step. I will go for the first element. What's the first element? A11. I will remove the row and the column. The remaining value will be a matrix less than 2 by 2, which is going to be, say, 1 by 1, which contains A22. So it's exactly like multiplying A11 by A22. Then I will go for the second number on the first row, which is A12. Same way like, I will multiply A12 by this rule times eliminating the row and columns. The remaining number is going to be A21, which is a matrix less than the dimension by 1. Are you with me? Are you following me? Okay. You will end up having multiplying the elements of the principal diagonal minus the elements of the secondary diagonal. معايا فيصل؟ زياد انت فاهم انا بقول ايه؟ Okay. Hello, Surat. Okay, so for evaluating a determinant of A, 2 by 2, I'm not going to go through all of this. You already know it. But I'm telling you from where it came. Okay? Fine.
الماتريكس دي مثلا تمام؟
دي 3 by 3.
كنت قلت لنا طريقه كده نجيب منها الفيرس ان احنا ناخد رو 1 1 1 2 1 3 بعد كده 2 1 2 2.
طب بس خليك كده شويه.
لا مش فاهم هو انا مكملين. لا مش ده.
طب مش ما اقدرش اناقشك دلوقتي في ذكرياتك. انا بتكلم دلوقتي ان سبيسيفيك هاو تو ايفالويت الديترمنت. طبعا داخل فيه اللي انت بتقوله ده. How to evaluate a determinant of a certain matrix. Mainly, we evaluate a determinant for a certain matrix using Laplace rule. Rule اللي هنستخدمها. Okay? طيب Laplace rule دي بتقول ايه؟ فريد. But choose a line or row. خلي بالك. We already have a lot of this information we are using in the previous lectures. But here in a specific way. So for a 2 by 2 determinant relative, it's very easy to evaluate, as you already know that if I want to evaluate the determinant of this matrix, I will multiply the elements of the principal diagonal minus the elements of secondary diagonal. هو في حد فيكم مش عارف ده؟ ده انت عارفه صح؟ طيب هو جه منين؟ It came from the fact that in order to evaluate a value of a determinant, I will choose any row or any column. I will choose mainly for this matrix the first row. So the first row will start with A11. So it's A11. But the sign rule is -1 to the power of the sum of the row and column. So it's going to be -1 to the power of 2 times the determinant of the matrix corresponding to this element. The determinant of the matrix corresponding to this element, eliminate the row and column, it's going to be A to 2. So, and it is exactly corresponding to multiplying the elements of the main survey. From where the negative sign came, the negative sign came from having a -1 to the power of 1 plus 2, which is the sum of the row and column of the second element. So it's a -1 times A12. Eliminate the row and column, it's going to be A21. Okay? So it's multiplying the elements of the principal element minus the elements of the second element. If I went to 3 by 3, that's the main method of evaluation. We took two methods, the Saras rule, and we also took the cofactor method or the Laplace method. I will do it with you step by step. I will go to the first element, A11, eliminating the first row and first column. That's going to be the matrix, which dimension is less than this one by 1, which is going to be 2 by 2. معايا فريق? Then I will move to the next number. The next number is going to be A12 times, remove this first row and the second column, and those are the remaining elements from this matrix. So it's going to be simply A11 times the sign rule, which is -1 to the power of 2, because the sum of these two number of rows is equal to 2. Then the determinant of the corresponding matrix for the first element in the main matrix, which is a 2 by 2. Okay, similarly, like I will go for the element A12. That's the element A12 times -1 to the power of the sum of rows and columns times eliminate the row and column. That's the determinant of the matrix corresponding to it, and so on. Okay, so here how we can evaluate a determinant for a 3 by 3. Okay, very good. And these are the results. Don't look to the results with the symbols. The results with the symbols in order to take your hand at the beginning. But you already know all of this. Okay? Let's go to the second step. Okay. In this paragraph, or in this part, it is written here some statements about what we have here. Okay, the first statement, the previous definition of determinants enables the computation of the determinant of a matrix of order n, with n is greater than or equal to 2, via computation of the determinant of n matrices of order n minus 1. Let's look at specific to this couple of lines. If I want to evaluate the value of the determinant, okay, the value of this matrix, if I want to evaluate the value of the determinant of this matrix, how to evaluate the value? This is in a second. How to evaluate the value of the determinant of this matrix? Anyone? How to get the value of the determinant of this matrix? So like, if this is A matrix, so the determinant of this A matrix can be done. How to do it? I'll try to apply the rule that we have already, which states that I will go for the element, the first element, which is 3. That's the element 1 on 1. Multiplying it by -1 to the power of 2. It is the sum of the two elements of row and column. Times eliminate the row and columns at the corner of this number. So eliminating the first row and first column. What's going to be the matrix? It's going to be the remaining numbers 0, 3, 1, and 2. Then I will go for the second number. What's the second number? 4. So it's going to be a plus of a 4 times a -1. The dimension here is first row, second column. So it's going to be to the power of 3. Then try to get the value of your matrix. Once more, عمرو. لو قعدت هنا خلي بالك من الكاميرا. Okay. Once more, 4 in a regular one column, so the numbers are going to be 2, negative 1, 2 and negative 1, 3 and 2. Then plus, I will go for the element of the last one, which is going to be this right, 1 times negative 1. Mr. Ziad, الباور بتاع negative 1 يبقى بكام؟ 3 and 1 يعني 4. Okay, negative 1 to the power of 4. Then I will eliminate the row and column. Eliminate the row and column. هيديك كام؟ 2 0 negative 1 1. Okay. فريد. Dimension 3 by 3. Dimension 3 by 3. Once we try to evaluate the determinant, we are evaluating 3 matrices or 3 determinants. Each one of them is 2 by 2. Are we right? Okay. That's the statement that was stated here. That statement موجود عندك في الأول. إن أنا علشان evaluate an n by n matrix in order to evaluate an n by n matrix, you will find determinants of n matrices of order n minus 1. So in order to evaluate a matrix 3 by 3, I end up having 3 determinants, each one of them 2 by 2. Like if I want to evaluate a matrix which is 4 by 4, I will have to evaluate 4 determinants, each one of them 3 by 3. And the statement is here, when n is equal to 4, we have 4 determinants, each one of them is 3 by 3. And each one of those 3 by 3 is going to be expanded to 3 determinants 2 by 2. And each one of 2 by 2 will be expanded, you can expand it using this method to 2 determinants, each one of them 1 to 1. Which means if you want to evaluate the value of a determinant of order 3, okay, you will end up having factorial 3 of braces of numbers, of values. If I want to evaluate a determinant 4 by 4, you will end up having a factorial 4 times 3 times 2 times 1 elements. Okay? This is an obstacle in front of the methods that's using matrices. So here once more, 4, it will be expanded into 4 determinants of matrices of 3. Each one with 6 braces. Why 6 braces? Because each one of 3 by 3 matrices, it will be expanded into 3 2 by 2. And each one of the 2 by 2, it will be expanded into 2 elements. So if you multiply 2 by 3 by 4, you will end up having the 24 or the n factorial of number of braces. In the general case, a belongs to n by n, the formula of determinant has n factorial braces. So it's a huge number of values to be evaluated. If A has order n, with n is greater than or equal 4, it might be painful, okay, to complete the determinant of A. This is one of the major disadvantages of using determinants. Okay, what's an algebraic complement? The algebraic complement, it means multiplying negative 1 in the determinant of I and j. Actually, I'm giving you all of this information, although you already know them, but I'm giving you this in order to introduce in specific what's an algebraic complement, because you may be asked about it in the exam. What's the algebraic complement? Once more, in specific, it is the sign rule times the determinant of the matrix assigned to this number. So, if I asked you about the algebraic complement of the element I and j, all you have to do is to get the sign corresponding to this element times the determinant of the cofactor matrix or the assigned matrix to the 2 elements I and j. For example, this is really, very important. For example, this matrix, which is the 3 by 3, I need to find the matrix 3 by 2. I need to find the matrix 3 by 2. مين هي الماتريكس 3 by 2؟ فيصل. Where is the matrix 3 by 2? 3 by 2. Third row, So the matrix will be 1, 2, 4, and 5. Am I right? Third row, I'm sorry. Third row, second column, I'm sorry. So it's going to be 1, 4, 3, and 6. Are we okay? عايز الماتريكس اللي بتناظر الاليمنت 3 و2. فين الاليمنت 3 و2 الاول؟ ده ثيرد رو الرقم الاولاني وسكند كولم اهو. اليمينيت them شيلهم. شيل ده وشيل ده. مين النمبرز اللي فاضله؟ مظبوط كده صح؟ دي كده اسمها الماتريكس assigned to the element 3 and 2. طيب لو انا عايز اجيب الالجبريك كومبلمنت هيبقى الفاليو اوف ذس ماتريكس اللي هي 1 4 3 and 6 بس مش تنسى تايمز الساين which is negative 1 to the power of 3 also. انا باكسبت الافورت ده زياده انت عارف ده انا متخيل انك فاهم ده. لو انا عايز اجيب الالجبريك كومبلمنت هحط الساين واجيب الديترمنت. بس انا عايزك تبقى عارف يعني ايه بالظبط الجبريك كومبلمنت. You need to know this exactly because in the exam you may be asked it for a trivial question. يا عمرو, he will give you a matrix and then he will ask you in specific about the algebraic complement about the element, one of the elements, and if it is true or not. So you will have to know that I will take the sign rule plus the value of the determinant of this matrix. Okay? Okay, perfect. يبقى ده معنى كلمة algebraic complement. Of course I will evaluate it. 1 times 6 is going to be 6 minus 12, so it's going to be negative. 6 times negative is going to be positive. Another information about the alternatives in the exam. Sometimes the alternatives are very close to the correct answer. So he can ask you the algebraic complement of the element 3 by 2 is equal to 6. And he's asking you in a path to state the right or to choose the right statement. So it's going to be great. Another question maybe with the same contents and answer. The algebraic complement of the element A32 is negative 6. The correct answer is 6, but he's giving to you is negative 6, which is very, very close. Are you understanding what I'm saying? فاهمين يا بولي؟ يعني ممكن بسهولة جدا يسألك على algebraic complement ويروح موقع لك الإشارة بتاعتها. الرقم هو مظبوط بس الفرق إيه؟ إشارة. فاهمني؟ فاهمين بقول إيه؟ أنتوا ليه مديكيني إنديكيشن أنتوا مش فاهميني؟ عشان كده أنا بريبيت ماي سيلف. أول ما بحس إن أنت باصص لي مش فاهم فبالتالي بعمل إيه؟ بعيد أوتوماتيك. أوكي؟ أتمنى حضرتك تكون فاهمني. طيب انزل. Following the previous definition طبعا خلاص هو بيعرفها بقى يعني ايه ازاي بقدر اجيب الديترمنت. خلي بالك ان الديترمنت of A of this matrix is equal to element A11 times the algebraic complement of A11. تاني كمان مرة يا عمرو. انا بضرب الاليمنت 11 في الالجبريك complement بتاعت A11. فاهمني؟ في difference between them. عشان كده انا قاعد عمال اكد على النقطة دي. لانه انا متخيل ان لما باجي احسب determinant I will get the numbers of the rows whatever. I will multiply the number by the algebraic complement. I usually do that. But sometimes the questions are within a part of a context like this. So he's going to ask you about the algebraic complement. That sign will make a difference. Okay? Continue. Here's how to evaluate. Okay, we know already the determinant of A and so on. The expressions once called the development of the determinant of A, how to evaluate, and it is called Laplace theorem. So this theorem that we used previously, it's called Laplace theorem. As I told you once more, it's called Laplace theorem on a line, on a row. I can apply it on Laplace theorem on certain line, which means certain row, or apply it on a certain column. It will make no difference, which you already stated previously. If I want to evaluate the value of the determinant of this matrix, you will have to choose any row or any column. Why? They are all the same. And the value of the determinant will be the same. It's not going to be affected by the row or the column as long as you are considering the sign rule and the correct algebraic complements. معايا يا جماعه؟ اوكي. خلاص. Okay. This is okay. There's no problem in this context. Choosing any row or any column and applying the Laplace theorem in this paragraph, it will make no difference in the value of the determinant. So this is the symbolization of this one. Oh, before we go to the next slide, I want you to take a good care of this remark to Mr. Ziad. If I'm evaluating a determinant of a matrix and it has a 0 element, so the result of this determinant is going to be 0. So if you have a complete row or a complete column equal to 0, the value of the determinant is going to be 0. You don't have to evaluate it, okay? Okay, those are very important ones. What's remark, example on applying the Laplace theorem on every row and every column of this matrix. Let's go to this matrix. عمرو أنا عايز أحسب الdeterminant. I want to evaluate the determinant of this matrix. How to evaluate it? قول لي إزاي أحسب الdeterminant؟
determinant بتاع ايه؟
علي صوتك.
هو determinant بتاع ايه؟
بتاع الماتريكس دي عايز أعرف determinant of إيه؟ هحسبه إزاي؟ اختار أي صف يعجبك. إحنا عادة بنستخدم الفيرست رو. طيب بعمله ازاي؟ بجيب الديترمنت ازاي؟ باجي على الاليمنت الاولاني اللي هو 1 اشيل الصف والعمود يبقى 1 اشيل صف واشيل عمود يفضل 5 0 0 2 بعدين احط الساين رو which is negative اخد 9 اشيل الصف والعمود الاليمنت اللي تفضل 4 0 0 2 بعدين بلس اروح على 3 تايمز اشيل صف وعمود 4 5 0 0 اوكي؟ Can you apply this on any other rows؟
ممكن second row
والثird row مش ما يقولش حاجه صح؟ But the only thing that I'm telling you about is once you are trying to apply this rule, okay, it will make no difference between any row or any column. You can choose any row or any column. But I would usually prefer to use the row or the column with the hugest number of zeros. مش مهم ايه؟ افتح. ألف مبروك. عايز أحسب قيمة المحدد ده بتاع الماتريكس دي 3 في 3 على أي صف وأي عمود. رأيك أستخدم مين؟
احنا المفروض نطبق نفس التطبيقات الأول.
إيه؟
هنطبق نفس التطبيقات الأول مش كده؟
الصف الأولاني أوكي ما أنا قلت لك عليه.
إنما نفس الكلام مع السكند والثيرد رو.
طيب أنه أحسن say that. If I want to evaluate the value of this determinant quickly, what's going to be the best? The third row. Why the third row? It has a lot of zeros. معايا Mr. Farid? If I want to evaluate the value, if I want to evaluate the value of this determinant, I would choose the third row in specific. Why the third row in specific? Everything is correct. If you choose the first, second, first column, second, all correct. But it will be better for you to choose the third row. Why? Because it contains double zeros and just only a number. So if I use the third row, Mr. Omar, the first element will be 0 times everything is going to be 0. You're not going to evaluate it. Then the second element will also be 0, so you're not going to evaluate. The last one is going to be 2. So this is the only one that you will evaluate. So it's going to be plus negative 1 to the power. The sign rule states it's a positive value because it's a 3 by 3. It's the 3 element. So sign rule معناه positive. So it's going to be positive times 2 be 2. Eliminate the row or column. هيفضل عندك 1 9 4 and 5. فريق ازاي اقدر احسب الفاليو بتاعت الديترمنت ده؟ 1 times 5 is going to be 5. Minus 36, which is going to be negative 31. Times 2, it's a negative 62. I can evaluate it by my mind. Okay, let's try it once more. Please try to take care of these silly parts. Okay, the first, I will start to evaluate the Omar from the first row. Mr. Omar, how many determinants do you have? 3 of them. If you remember, or if you remarked the previous slides, this one I'm not going to evaluate. Why I'm not going to evaluate this one? Because it contains a row of zeros. So it's equal to 0. I'm not going to evaluate. So I'm evaluating just only this one, which is 5 times 2. Of course, minus 0. This one, which is 4 times 2, which is 8 minus 0. You will be able to evaluate. It's negative 62. If I want to evaluate of the second line, it's going to be similar. So all I have to do is to evaluate the value of this determinant using the second line. Okay, if I want to evaluate using the third line in just only one determinant, this is why we choose it. Same result for the previous slides. This is negative 62, negative 62. That's the third row, negative 62. I also can use any of the columns. The first column, second column, third column. This is the value of evaluating with first column. That's the value of the determinant with second column. That's the value of the determinant with third column. All of them, the values are negative 62. يبقى هنا practical, we are not going to do this more. It's just to indicate that expanding a determinant using any row or any column, the value will be the same in front of your eyes. But you should choose the smarter choice. What's the smarter choice? For this determinant or the determinant of this matrix, I will stop for a second and look to the rows and columns. I will discover that the third row contains plenty of zeros. So I would recommend expanding by the last one. Are you with me? Okay. Those remarks are really very important. الملاحظات اللي انا هتكلم عليها دلوقتي غايه في الاهميه. من فضلك لا تبص في الموبايل ولا تسرح ولا اي حاجه. The first statement, the results about determinants that are stated using lines are still valid for line or a column, which means every remark that you will see now, it's applied for both lines, rows or columns. اللي بقول على rows مش على columns. مش مشكله بالنسبه لي. Okay, if A is an n by n and it has 0 row or 0 column, the value of the determinant will equal to 0. You don't have to evaluate. This is number 1. Number 2, for A n by n matrix, if A has a line that's equal to a line J, if it has 2 rows equal to each other or 2 columns equal to each other, the value of this determinant will equal to 0. You have 2 propositions, very important. If you have a complete row in a matrix, then the value of the determinant assigned to this matrix is equal to 0. If you have 2